Hello everyone, my name is Bilal Miari. In this video I am going to talk about tabular method or DI method, which is a special technique of integration by parts. Let's begin. So let's revise the integration by parts. Integral UdV is equal to UV minus integral VDU. Example, integral x squared sine x dx. In this case, take u equals to x squared and dv equals to sine x dx. Then du is equal to the derivative of x squared dx. The derivative of x squared is 2x. And dv equals sine x dx. Integrate both sides, we got v equal integral of sine x is minus cosine x. Apply the integration by parts, uv minus integral v du. Then we have minus x squared cosine x plus 2 outside the integral x cosine x dx. Apply the integration by parts again on the integral x cosine x dx. Let u equal x, then du equal to dx. And dv equal cosine x dx. Integrate both sides, we got v equal sine x. The integral of cosine x is sine x. Then apply the integration by parts, uv minus integral v du. We got minus x squared cosine x plus 2 factor uv x sine x minus integral v du minus integral sine x dx. But the integral of sine x is minus cosine x. We got minus x squared cosine x plus 2 factor x sine x plus cosine x plus constant. So this is the final result, minus x squared cosine x plus 2x sine x plus 2 cosine x plus constant. In this case, I will explain how to integrate these integrals by using a tabular method or DI method. First case, integral p of x sine x dx, integral p of x cosine x dx, and integral p of x ex dx, where p of x is a polynomial function. Let's now calculate the same integral as before, integral x squared sine x dx. In this technique, we form a table of 2 columns. The first contains derivatives and second contains integral. And we begin with the sign plus, minus, alternating. In case of polynomial, we take the polynomial in D column, then x squared in D column, and sine x in I column. Then in D column, differentiate x squared, we get 2x, then the derivative of 2x is equal to, and the derivative of 2 is equal to 0. In I column, integrate. The integral of sine x is minus cosine x, and the integral of minus cosine x is minus sine x, and the integral of minus sine x is cosine x. Then multiply diagonal. First term of D column with the second term of I column. We got plus x squared times minus cosine x, we got minus x squared cosine x. Minus 2x multiply minus sine x, we got minus plus 2x sine x, and plus multiply 2 with cosine x, we got 2 cosine x plus constant. Example 2, integral x cubed cosine x dx. In this case, take the polynomial x cubed in D column and cosine x in I column. Differentiate x cubed to get 0. The derivative of x cubed is 3x squared, then 6x, then 6, then we get 0. The integral of cosine x is sine x, the integral of sine x is minus cosine x, and the integral of minus cosine x is minus sine x, and the integral of minus sine x is cosine x. Multiply diagonal, plus x cubed times sine x, we get x cubed sine x, and minus 3x squared times minus cosine x, we get plus 3x squared cosine x, plus 6x multiplied by minus sine x, we get minus 6x sine x, and finally minus 6 times cosine x is minus 6 cosine x plus constant. This is the final answer. Example 3. Integral factor x cubed plus 2x squared ax dx. In this case, take the polynomial x cubed plus 2x squared in d column and ax in I column. Differentiate d column to get 0. Then we have 3x squared plus 4x, then 6x plus 4, then 6, then 0. Integrate ax is ax, 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 ax. Multiply diagonal plus factor x cubed plus 2x squared by ax minus factor 3x squared plus 4x by ax and plus factor 6x plus 4 by ax and finally minus 6 by ax plus constant. Simplify to get factor x cubed minus x squared plus 2x minus 2 ax plus constant. Case 2. Integral x ln x dx. In this case, take ln x in d column and x in I column. Differentiate ln x, we get 1 over x. Integrate x, we get x squared over 2. Stop here. Multiply ln x by x squared over 2 minus integral x squared over 2 times 1 over x. We got x squared over 2 ln x minus integral x squared over 2 times 1 over x dx. X squared over 2 ln x minus, simplify and get half outside the integral. We got minus half integral x dx. Then we have x squared over 2 ln x minus 1 over 4x squared plus constant. This is the final answer. Case 3. Integral ex sin x dx. In this case, you can take ex in d column or I column. Then take sin x in d column and ex in I column. Differentiate sin x until the sin x is appear again. The derivative of sin x is cosine x. The derivative of cosine x is minus sin x. Integrate ex, we got ex, ex. Then multiply diagonal sin x by ex minus cosine x ex plus times minus minus integral ex times sin x. We got ex sin x minus ex cosine x minus integral ex sin x dx. Take minus integral ex sin x dx to the left hand side. We got 2 integral ex sin x dx equal ex sin x minus ex cosine x. Divide by 2. We got integral ex sin x dx is equal to half factor ex sin x minus ex cosine x plus constant. Thank you. Goodbye.